Okay, so we'll start now. In last session, we have discussed about the bolted connection, how to get the bolt capacity in bearing, and bolt shear capacity. Today, we'll see about the welded connections. What is the welded connection? How to calculate its strength? What is its thickness? What are type of the weld? How we can denote it on the drawings? We will go through that, and if possible, we'll go through some examples of connection design. So let's start with first advantages and disadvantages of the welded connections. So advantages are, I think in last session we have seen that, but still we go through it again. Advantages are as there are no holes in the welded connections. So the net available area is the gross area of the section. So it gives more strength as compared to the bolted connection in axial when the load is acting in axial direction. Here we have less connecting elements, like we have only gusset and to which gusset which will be welded to the beam section. So there are no nut and bolts, so the weight of the connection is less. Welded connection looks good as compared to the heavy bolted connection. So if there are so many number of bolts, in that case we required somewhat heavy gusset or length of the gusset, and its shape becomes sometimes odd when we use or when we required more number of bolts. So in as compared to that, welded connections are is simple and easy, and it it will not accommodate that much space also, and it looks good when we required any architectural preference or architectural view. So in that case, we can use the welded connections. Now, what are the disadvantages of the welded connection? Welded joints are brittle and hence their fatigue strength is less. So as we put a weld, it becomes fixed type of connection, and it becomes a brittle connection. So its strength during fatigue failure is very less. It is a hot process, right? We are hitting the two metals to join each other. So it is a hot process, and there could be a chance of development of internal stresses, temperature stresses in the member. Then skilled labor is required when we do welding at a certain elevation or at a high elevation. At that time, we need a skilled labor so that the weld should be properly deposited and there should not be any pocket left in the weld. So as its strength should not get reduced. Then provision of expansion and contraction joint is difficult in case of welded connection because it almost provide a fixity or fixed type of connections when we join two member each other. It almost become a fixed type of connection. So it is difficult to achieve the expansion or contraction joint in case of welded connections. And inspection of weld is difficult. So inspection by visuals or by naked eyes is difficult. Sometimes when we have a heavy load on the members or any equipment is having heavy stresses, in that case that weld has to be checked by the radiography test, which is difficult and costly also. So its inspection of weld is difficult. Now we'll see the next type of the welds. What are type of the weld? So there are basically three types of the weld: fillet weld, butt weld, and plug weld. Fillet weld is used when two members are connecting or at orthogonal to each other. Just a moment. Fillet welds are used when two members are connecting to each other orthogonally or overlapping to each other. In that case, we are using the fillet weld. Then butt weld is used when we want to connect the two metal in the same plane. In the same plane means there is no overlapping, or both the plates or members are having their top or bottom at the same elevation. So in that case, we use the butt weld, and plug weld is used when we want just a small weld or just a temporary weld wherever required. At that location, we use the plug weld, but plug weld will not be used as a design weld or for any strength requirement. Mostly fillet weld and butt weld is used. Out of that, fillet weld is commonly used everywhere, whereas butt weld is used when we want very high strength or the load transferred by the column or any section is very huge. In that case, we use butt weld type of connections. And there are some weld symbols. So these are all butt weld symbols. So what it shows, this is square butt weld, this is square butt weld, single V butt weld. You can see those both the surfaces are cut so that V shape is formed between these two surface, and weld is deposited between these two slanted edge. That's why it is forming a V shape. That's why it is called single V butt weld. This is single V butt weld. This is single U butt weld. U shape of cuts are provided in the section, and weld is deposited between that gap. Single J type butt weld, backing run. Then fillet weld. This is a fillet weld where we can see two members are connecting at orthogonal or perpendicular to each other. Plug weld, and this is spot weld. Okay, how we have to show the weld on the drawing? Whenever we provide any weld on the drawing, or we want to denote the thickness of weld, its length, and for how many sides it is, then we have to define by this mark. This is a standard weld symbol which we use to show which type of weld is provided. So this is arrow. When we provide a triangle here, so this triangle denotes it is a fillet weld symbol, right? It is a fillet weld symbol. If we just provide two vertical lines here, right? If you just provide two vertical lines, it means it is a square butt weld, right? It is a square butt weld. If we provide this V-shape type of symbol here, it will be a single V butt weld. So this whatever we diagram denote here, or any shape if we put it here, it will denote the type of the weld, or what type of the weld, or what type of connection will be there. So when we provide a triangle, it is a fillet weld. In this one, it denotes the leg size or size of the weld. So if my weld size is 3 mm, then I will write it 3 here. If it is 6, then I will write it 6. Okay. So this is 10. Sometimes we used to write a typical just beyond this in the bracket, so that the same weld size and weld symbol will be used at other locations also. So now when we put the arrow and all the symbols are same as that of first one, but only difference you can find it, there is a circle at the intersection of the two lines. So this circle denotes all around weld. So when we provide any plate, right, any plate or any gusset, so all around means whatever surfaces are available for that plate. So all those surfaces shall have a weld. So it is called all around weld. Means wherever we get the possible to put the weld, all those locations we shall put the weld when we say all around weld. Now in the above symbol, if we just add a flag in it, so this flag indicates filled weld. So this flag means this weld is of fillet weld, and it is all around, but it has to be done on the field. If it is without flag, then it is to be done at shop. If it is with a flag, then it will be done on the site or field directly, right? So flag indicates the field weld. Then in another case, when we provide a fillet weld, and if you write the 1-4 or 1-3 or any number it like here, so it is called an intermittent weld length and pitch. So this one you will define the weld size or length of the weld, and 4 will denote the pitch of the or spacing of the weld. So this type of remark or this type of marking we need in case of the girder design, where we put intermittent weld for the flange and the web. So in that case, we define this intermittent weld in this fashion. One will denote your weld length, and four will denote your spacing between the welds. Now, when we have the arrow on both the sides, so it denotes fillet weld on arrow and opposite side, right? So if this is my one side, then opposite side will be this one, right? So in that case, I'll just denote a arrow on this side and I'll put a triangle mark on top and bottom, so that it will denote the same type of weld will be on other side also. So this is just for the other side of the weld, and this is also for the other side of the weld, but in staggered manner. If you just see, these two triangles are little bit staggered, those are not in the same line. In this case, these are the in same line. So wherever the one side of weld is started, the other side weld will start from the same location, but in this case it is staggered. So here the other side weld is staggered, and its spacing and its length, weld length, is same as that of the one side, but only thing is that it is little bit staggered. So these are the symbol for the weld. You can use different shapes to show the type of weld, whether it is a butt weld or single bevel butt weld, so or fillet weld. So this will be your weld indication on the drawings. Now let's see the fillet weld first. So when two plates are overlapped each other, then those are connected by fillet weld. So as we discussed, when two plates are overlapped, or if the two plates are intersecting with each other at 90 degree, then we have to use the fillet weld. And what is size of the fillet weld? So the length of the weld from root to the toe is the size of the weld. So we need the size of the weld, right, to get the its strength, or to get the capacity of the weld. We need size of the weld. So what is size of the weld? The length of the weld from toe. The length of the weld from root to the toe is the size of the weld. So this is from root to the toe. It is the length of the weld. So this LS is the length of the weld. In the other direction, from this root to the toe. So this will be the LS. So it is uh, same in both the direction. Okay. When the minimum size of fillet weld is greater than the thickness of thinner part, minimum thickness of weld shall be taken as thickness of thinner part. So when the minimum size of the fillet weld required is greater than the thinner part, if we have two plates, one is of 6 mm, other is of 10 mm. So in that case, we should not provide weld according to the thickness required for the 10 mm thick plate. It should be according to the 6 mm. So maximum thickness or uh, maximum size of the fillet weld shall be 6 mm, because the minimum thicker or thinner part between the two plates is 6 mm. So our length of the weld or size of the weld will be 6 mm, right? So as per our IS code, the first run of the single run fillet weld. So if we want to put a 6 mm weld, right, we want to connect these two plates by 6 mm weld, but it is not possible, or it is not recommended to put 6 mm in a one stretch if the two plates are having different thicknesses. So the code has specified that the single run or first run of the weld shall be of this much size when we have a different sizes of the plate. So when we have a plate size, thickness of the thicker part, if it is 10 mm, then first run shall be of 3 mm. If you want to apply a weld thickness of 6 mm, then first we should apply a weld of 3 mm. Then after some time we have to apply a weld of another 3 mm. So that will make a cumulative 6 mm of weld. So can you guess why we need to apply this kind of weld? Any guesses? if you put a 6 mm of weld in first run, what will happen? Any guesses? This plate is of 10 mm thick, and why we cannot put 6 mm at a single run? Actually, if you put a 6 mm of weld in a single run, then it will generate so much of heat that the 10 mm thick plate will get thinner, or there will be a reduction in its size due to this welding. So instead of putting 6 mm of weld at one stretch, we normally put 3 mm when the when the thickness of thicker part is 10 mm. If it is between 10 to 20, then first run will be 5 mm. 20 to 32, first run will be 6 mm. 32 to 50, 8 of first run, right? So it is as per this code, we have to specify, or we have to mention on the standard drawing, that first run, or the fabricator has to follow the IS code format or IS code recommendations for the weld length. Okay. So throat of the weld. What is throat of the weld? So for right angle fillet weld, throat thickness is given by this below equation. This T is throat thickness, that will be equal to K into S. So what is this K? K is constant based on different fusion angles between surface. So this is the fusion angle. In this case, it is 90°. Sometimes you will have some inclined plates which you need to connect. So that will have some different K values. So as per IS code, we have different K values for the different fusion angles. If you refer to the code, these values are given in the code. So when it comes to 90°, the K value becomes 0.7, and S is the size of the weld or thickness of the weld, right? So your throat thickness will be 0.7 when it is a 90° of angle between two plates, and S will be your throat S will be your thickness of the weld. So effective length or area of the fillet weld. The effective length of fillet weld shall be taken as only that length which is of the specified size and required throat thickness. So effective length will be taken only what the required size, right? Specified size, or as per the design, what size we got, that specified size and its required throat thickness. In practice, the actual length of the weld is made up of effective length shown in drawing plus 2 times the weld size, right? So even on the drawing, if you specify a length of 100 mm, that is only the effective length required to take that much of load. But when you go on site, you will find it that weld length provided is little bit more than the specified on the drawing. So that weld, from where that additional comes, that additional length will come from this effective length plus 2 times the weld size. So this is called end run. We normally provide end run, so this is 2 times of the weld size. So this is additional length is provided on the during the welding. So total length will be effective length plus 2 times of the weld, and it should not be less than the 4 times the size of the weld. So total length should not be less than 4 times the size of the weld, because two times of the weld on either side. So it should be minimum 4 times of the size of the weld. So this is the total length, right? So how to get the fillet weld capacity? So fillet weld capacity, it's a design strength of the fillet weld. We got it from the fillet weld stress, right? We use some material for the welding. So stress, ultimate stress of the that material divided by √3. This is a factor of this is √3. This is general equation. So Fu is the smaller of ultimate stress of the weld or the parent metal, right? So whatever material we are using for the welding, its ultimate strength, or if the plates are there, then ultimate strength of the plate. So whichever is smaller, that we have to use. Most of the time plates are having less yield strength or ultimate strength as compared to the weld capacity. So most of the time you will find that Fu will be the ultimate tensile strength of the plate is always governing to get the capacity of the fillet weld. And gamma MW is a partial safety factor. It is given in IS code. It is case 1.25. Okay. So based on this, we will get the fillet weld capacity, and we'll see how to get in during example. We'll see how we can calculate these capacities and how to check against the load. Then butt weld. So when we want to connect two plates in plane or in the same direction, in that case we normally use a butt weld symbol or butt weld joint we use. We deposit the weld between two plates so that it can form a parent. It can give the strength equal to the parent metal. When we have a ultimate, when we connect two plates, and if we deposit weld between these two plates, so this joint or this weld will behave as a parent metal, and it will provide the same strength as that of the whatever plate strength we have, right? So that is the biggest advantage of the butt weld. So it gives you the capacity same as that of the plate material, right? Then what size of the weld? The size of the butt weld is the thickness of thinner part. Since we are depositing the weld between the two plates, right? We have one plate thickness T here, T1 and T2. If T1 is less than T2, then T1 will be the my throat thickness of the butt weld, because the maximum surface available to deposit the weld is T1 thick, right? So this we deposit in the between two surface, and T1 will be the minimum or the size of the thinner plate will be the size of the weld. The effective throat thickness of the full penetration weld is equal to the size of the thinner part. So in this case, the effective throat thickness will be same as that of the thickness of the thinner part. So these are the type of butt weld or joints. Here, this is single square groove. This is single bevel groove in which the V-shaped type is created between two plates. So this you can see all the plates are connecting in the same plane with some different joints or different shapes provided to plate to deposit the weld. So by this you can define different shapes or types of the butt weld. Now throat thickness of the butt weld. Partial penetration. For partial penetration, whatever. So butt weld has two different types, right? One is full penetration, another is partial penetration. So full butt weld means we deposit the complete weld between two surface top up to the full depth of the joint. And in case of partial butt weld, normally we provide it the weld up to the half or up to the certain extent of the plates, so that it can be specified as a partial butt weld. So partial penetration, the effect in case of partial penetration weld, the effective throat thickness is taken as 7/8 of the thickness, and for weld strength calculation it is considered as 5/8 of the thickness of the thinner part. So this is why, because on the drawing we will specify that the throat thickness of the weld is 7/8 of the thickness of the thinner part. So in this case we are defining the more thickness, whereas during calculation we are considering the less thickness of the butt weld. So on drawing we are specifying more, whereas while considering for the calculation we are on conservative side, we are considering the less thickness for the calculation, because we don't know the how much accurate they will deposit the weld, or how will be the manpower, whether it is skilled or not, or is it possible to weld at a certain height. So based on to take all those factors in account, we normally define the higher weld size on the drawing, and for the calculation we consider the minimum size of the weld. So when we want to connect two different plates, the difference in thickness between the two plates should not be more than 25% or 3 mm, whichever is more. So when we want to connect two plates, the difference between them should not be more than 25% of the thickness, right, or 3 mm. So that there is, if the thickness is more, and if you want to connect it with the butt weld, in that case, we the weld or the slope of the weld will be too much, and it will reduce the effective depth, or it will not be possible to get sufficient strength due to decrease in the or due to less thickness available at the joint, right? So this is why I'll just show you. So if we have one plate like this, and if another plate is like this, so in that case, we have to trim this plate, right, in up to this extent. So actually what we are doing, we are just trimming this plate from somewhere like this, so that we can deposit the weld between this surface. But because of that, we are just reducing the too much area of the plate, and we are making it bigger joint. So that's why it is not recommended to have the more thickness, or the difference between thickness is only maximum up to 3 mm, so that there will be a proper slope of the weld, and two material will get properly welded to each other. If the difference is more than 25, then tapering is required of 1 in 5. So what tapering we have just seen, that is required, but its slope should not be more than 1 in 5. Effective length for butt weld shall not be less than 4 times size of the weld. So this is same as that of fillet weld. Now stress of the weld shall be taken as same as that of parent metal if welding is done in the shop, and it shall be reduced by 80% if site weld is provided. So when we provide butt weld, then we are considering that the whatever strength or whatever capacity that parent metal has, the same capacity we will get it for the welded joint. So but when that will be considered, when the it is done on the done in the shop, because in shop you have controlled environment where you can put properly you can properly weld to surface, you can check the welding, or there is very rare instance where it is not possible to weld. So in the shop it is controlled, and everything you can provide as per the standard. So you can consider the weld joint capacity as full capacity. But when we do the same kind of welding on the side, due to the skilled manpower availability, then elevations, then alignment of the members, because there could be some misalignment during erection of the member. So considering all these factors, we have to reduce the strength of the weld by 20%. So we consider 80% of the weld capacity for calculations. So this will be applied for the fillet weld as well, not only for the butt weld, but for any type of weld we have to consider. If it is a filled weld, then we have to consider the capacity as 80% instead of considering 100%. So design strength of butt weld in tension, it is Fy into Le is the effective length of the weld, into Ts is the throat thickness of the weld, and gamma Mw is the partial safety factor. Fy is the yield strength of the smaller of the either plate or weld. It is same as that of fillet weld. Effective length of the weld, which will be minimum 4 times size of the weld, and throat thickness is same. It is the thickness of thinner part of the plates which we are connecting. So based on this, we can get the thickness of the weld, or the capacity of the weld, right? Now this is about the welded connections. We have some different types of the connections, right? Movement connections. When there are shear connections and movement connections. Shear connections are simpler one, whereas movement connection has different types, like when the load is lying in the plane or load is lying out of the plane. When load is in the plane, then it will create directly tension on the bolts, right? But when the load is not in the plane, and if it is out of the plane load, then it will create the shear and torsional stresses on the bolt. So we'll go through the examples of this type of connections. So then you will get or you will understand how these connections are there and how the stresses are getting developed on these bolts. So this is about theoretical about connections design. We'll go for the some connection design. If you have any doubt up to this, then just let me know before proceeding on the connection design samples or examples. Any doubts up to this point? Okay. So we'll start with the bolted shear connection. This is the first example. So in this, just to work out bolt capacity and check the connection, I will just assume that the shear force on the or shear force in the member or at the joint is 60 kilonewton and axial force is 80 kilonewton. These forces you can get it from the your STAD analysis, right? Whenever you perform the STAD analysis, these are the forces for the combinations. So maximum of that you can consider that maximum shear force and corresponding axial force you can consider, and the other case will be maximum axial force and its corresponding shear force. So based on this, I have just assumed two loads for shear force. I considered 60 kilonewton and axial force 80 kilonewton. FUB is the ultimate tensile strength of the bolt. It is 400, and Fy is the yield strength is 240. So I have considered grade of bolt as 4.6, right? 4.6 means 400 is my ultimate tensile strength of the bolt, and its 60% will be 60% will be my yield strength. So ultimate tensile strength is 400 and yield strength is 240. Bolt I assumed is 20 mm. Bolt pitch is 70 mm. Right? Bolt edge distance is 40 mm. So we have seen the minimum edge distances criteria. Those are minimum, but from range clearance or to tighten the bolt, based on that you can vary this spacing between the bolts. Bolt edge distance should be sufficient so that there should not be any failure due to tearing or tension in the members. Gusset plate. So this is the depth of the gusset plate which I have worked on based on the number of bolts and its spacing between the bolts and its edge distance. So here spacing of the bolt is 70 mm and its edge distance is 40 mm on either side. So 140 plus 80. So this gives me the total depth of the gusset plate, that is 150 mm. Then thickness of the gusset 10 mm and web thickness of the section. So the section what we are going to correct, we have considered that it is a 6 mm thick. Right. First, we have to calculate the shear capacity of the bearing bolts. Right. Bearing bolt capacity. How we can calculate? Fu. Fu is the ultimate tensile strength of the bolt into Nn into A and B. Nn is the number of shearing plane that are falling in the threaded portion. Right. Nn stands for this net area. Right. When the shear plane is at the threaded area, then Nn will be 1, and if it is a two-way shear or the shearing plane is in the shank area, then this ns will be 1. So in this case, since we are considering the single shear, in that case the number of shear plane that are falling in the threaded portion is 1, and net area will be say 78% of the gross area. So based on that, and this ns, since this is a single shear, there is no surface or shear surface. Surface is getting sheared off at the shank area, so this will be 0, and ultimately this ns into a and b will become a 0. So Fu is 450. So 400. Fu is 400 into this area of the this one will be the one for the sheared surface. Then its area, and it is considered as 78% of the gross area, so that we will get the net area or area reduced due to the threads and square root of 3, right? So based on that we got 56.59 as the net design strength of the bolt, and its design strength of the bolt will be divided by factor of safety, that is 1.25 gamma mb material safety factor. Based on that we will get the shear capacity of the bolt, that is 45.27 kilonewton. Now bearing capacity of the bolt, bearing means when the bolts are getting beared against the either plate or the gusset, that we have to calculate. That we calculate by NB is the 2.5 into KB into diameter of the bolt into thickness of the thinner part into Fu. Fu is the ultimate tensile strength of the bolt or plate, whichever is less. So in that case, KB depends on what? Its edge distance, pitch of the bolts, ultimate tensile strength of the bolt, and yield strength of the plate, or 1. So whichever is minimum amongst all these, that should be our value of KB. So in this case, it will be 0.667. So our edge distance is governing the bearing capacity of the bolt. D is diameter of the bolt, T is thickness of the wave in this case, because thickness of wave is less as compared to the gusset plate. So before failure of the gusset, this wave will fail. So we have to consider the minimum thickness of the wave, and Fu is the ultimate tensile strength of the bolt. So here you can see we have considered minimum of these two, then thickness of the wave, which is minimum, and ultimate bolt dia is 20 mm, ultimate stress of the bolt. So based on that we got one more capacity of the of bolt, that is bearing capacity of the bolts, that is 64 kilonewton. So our shear capacity of bolt will be minimum of these two capacities, either 45.27 or 64. So minimum of this will be 45.27 will be my shear capacity of the bolt. So this will consider for the interaction check, right? Now tension capacity of the bolt. So tension capacity is the 0.9 into FUB is the ultimate tensile strength of the bolt into net area of the bolt. So based on that we'll get another one more capacity or tension capacity of bolt, that is 68.54, and tension capacity of plate will be depending on the net area available after deducting the hole. We have seen during our theory session, right? 0.9 into Fu. Fu is the ultimate tensile strength of the plate, and An is the area after deducting the number of holes from the total area of the plate. So that will give us the tensile capacity of the plate. So minimum of these two capacities will be our tension capacity of the bolt. So here it is 68.54. So we'll just note down here the bolt capacity in shear is 45.27, bolt capacity in tension is 68.54. So we have the shear and capacity, shear and tension acting on the bolt. So we just need to perform the interaction check to check whether the same bolts are sufficient to carry the shear and axial force simultaneously. So we'll just consider this ratio. We are getting the ratio of 0.78, which is less than 1. Hence, the number of bolts whatever we have provided are sufficient to take the actual load 60 kilonewton of shear and 80 kilonewton of tension, since the interaction ratio is less than 1. So clear this connection. This is a simple shear connections. Here we have checked the bolt's capacity and section also. Remaining is weld, that will check in weld shear connection. But if there is any query up to this, then just let me know.
And how to find An value?
An value is the 78% of the gross area of the bolt. If your bolt is of 20 mm diameter, then its gross area is 314, of which 78% you have to consider as a net value after due to the reduction due to the threads in the bolt. Clear?
सर ये
Sir,
केवी
Yes.
सर ये केवी का वैल्यू आपने इसमें से कौन सा हम लोग लेंगे? ये तीनों केस अप्लाई करना पड़ेगा?
नहीं, minimum of all of this, because it will govern the bearing, right? Bearing means क्या होगा कि जब आप किसी होल में बोल्ट लगाते हो तो वो किसके अगेंस्ट बेयर होगा और which factor will govern the bearing capacity. Here, since the edge distance is minimum, so that is governing amongst all this 0.667. This is the minimum value which we are getting. So we will use this value to get its bearing capacity of the bolt, because with these values we will get more capacity. Only this is the value where we can get the less capacity compared to the other.
Okay, sir.
Sir, bolt diameter is 20. So how you calculated as the bolt distance 70 between the bolt?
Minimum edge distance is 2.5 times of the bolt diameter, right? We have seen in our this theory. So spacing between bolt is minimum 2.5 times. This is a minimum spacing. So by 20 mm we are getting 2.5 into 20. So it is only 50 mm. So on conservative side, since we have this section of 200, if we consider MB 200, so after deducting the root radius, so for 200 section, if we deduct flanges, so 11 mm on both the sides, I guess, so 22 that will be deducted, and also if we reduce the root radius, so still we have 156 mm of plate or gusset.
सर थोड़ा धीरे सर.
Our section depth is 200 mm, right?
Okay, sir.
Flange thickness is around, for ISMB 200, it is around 10 or 11 mm. So we will deduct the two flanges, that will be a 22 mm. Then we'll have a root radius here. So this is a root radius, this curve, it is called root radius. So we have to connect our gusset plate below that root radius. So if I consider it is almost equal to the thickness of the flange, so you can get it from the steel table. So that root radius is 11 mm. So that will be on both the sides 11 11. So again we'll deduct 22 mm. So the available space for the gusset or available depth for the gusset is 156 mm. So in order to utilize all this space, so we have just provided the somewhat more spacing than the recommended one, because as per the recommendation it is 50 mm, but we have provided 70 mm, so that our capacity in bearing will increase, right? If we provide less spacing and less edge distance, then it will reduce the capacity further. So if I'm considering 64 here, so if bolt pitch is 50 mm, okay, as per the criteria minimum 2.5 times of the bolt diameter, so it will be 50 mm, and bolt edge distance will be 1.5 times of the bolt dia, so it will be 30 mm. So in that case my capacity will be reduced, considerably reduced. It is giving 48 kilonewton. Only if I make it say again 70 and 40 against 48, it will give me 64. So it depends on how much capacity you need. So it is always better to have some more edge distance and spacing than specified by the force, so that you will get the more capacity in the bearing, right? So 2.5 times is the minimum. You can go with that also, but only you have to take care of the maximum. You should not exceed maximum. So in between this, you can consider anything, whichever is good for the configuration of the connection. Okay.
Okay, sir.
So should we move on to the next connection, welded shear connection? So in welded shear connection, we have considered the same force, shear of 60 kilonewton and axial force of 80 kilonewton. The set plate thickness 10 mm. size of the weld 6 mm, then grade of the weld 410. So you can get these from different catalogs or weld electrodes capacity. Length of the weld. So here you can see we have provided this gusset of 200 depth, right? So we can provide weld on this side as well as on other side, right? So total length available for weld is 200 on this side, 200 on other side. Total length available is 400 kN, 400 mm. So now in case of weld, there are two stresses. One is normal stress and another will be shear stress. Normal stress is due to the axial force. So total axial force divided by the area of the weld, that will give me a normal stress. So that will be calculated by 80 kilonewton divided by 400 is the length of the weld, 6 mm is the size of the weld into 0.7. So 0.7 is due to the fusion angle between the two surfaces, and as per code it is 0.7, right? So this is the area of weld. Length into thickness will get the area of the weld. This is the total load. So total load divided by area, we will get the stress in the weld, which comes around 47.6 Newton per mm square. This is due to the axial force. Now due to the shear stress. So this shear stress is 60 due to 60 kilonewton. It is again load divided by area of the weld. So it is same. We got the shear stress. Now what we need is we need the combined action due to this shear force and axial force. So we just need to get the combined capacity or the combined stress which is coming on the weld due to the vertical shear force and axial tension or compression. That we will get it from this equation. This equation is provided in our IS code. So it is direct stress or normal stress square plus 3 into shear stress due to the axial force, right? This Fa is the normal stress and Q is the shear stress due to the tension or compression. So if we solve this equation, we'll get the net resultant shear or stress acting on the weld. So the resultant stress acting on the weld is 78.064, and that should be less than the Fu by root 3 gamma mw. Fu is the ultimate tensile strength of the electrode or weld divided by root 3 into gamma mw. So once we solve this, this will give us the maximum capacity of the weld, and capacity of weld is 189.37 Newton per mm square, and actual stress coming on the weld is 78.064. So our weld or provided weld length is sufficient to take this much of load. So this check you can apply to this type of weld, right? So you, in this case, you have checked the section size, you have checked the web of the section for bearing. So it is transferring the load from the bolt to the gusset plate. Gusset plate is already checked for the bearing because its thickness is 10 mm. So the gusset will transfer the load to the weld, and that weld will transfer load to the again web of the supporting member. So this weld we have checked here, right? We have checked the combined action or combined stress due to the same load which we have considered in earlier case. So now this connection is complete, right? This is a we are using two connecting material. One is bolt and other is weld. So first the member will transfer the load to the bolt, then bolt will transfer load to the gusset plate, and gusset plate will transfer load to the supporting member through the weld. So what we have checked here in connection, if you see the total connection, we have checked the web of the member, then bolts capacity in bearing, then gusset plate capacity in bearing and its tension capacity, and the weld capacity for the axial load and the shear load, right? So we have checked this complete connection, right? Any query in this welded type connection?
सर वर्किंग
हाँ।
स्ट्रेस मेथड और लिमिट स्टेट मेथड में क्या फर्क हो जाएगा?
वर्किंग स्ट्रेस में आपका स्ट्रेसेस अलग हो जाएगा. अल्टीमेट स्ट्रेस वी विल नॉट यूज अल्टीमेट स्ट्रेंथ ऑफ द वेट, because we are using service load combination in case of working stress, right? So the stress value will get reduced. It will not be a like 400. It will have some different values.
ओके, तो अभी इन करंट सिनेरियो कौन सी मेथड अभी यूज होनी चाहिए?
In nowadays we are using limit state method only, because our IS 800 2007 is based on that method only. So this is based on the our IS 800 2007, because the working stress or allowable stress methods are now no one is using.
ओके,
All combinations or all loads whatever we are considering, those are for the strength combination, like factored combination, not for the service combination. All loads are for the factored combinations.
यस यस.
Okay, so should we go to the next connection type, movement connections?
ना तो सर इतना तो रिवाइज कर लें सर.
इतना रिवाइज करेंगे.
हाँ सर.
प्रॉब्लम क्या है कि अभी जो सेशन होगा ना नेक्स्ट, तो वो नेक्स्ट वीक में होगा, मे बी आफ्टर मंडे.
कोई इशू नहीं सर, वो हड़बड़ी नहीं है हम लोग को, उतना पढ़ने दीजिए सर.
Because
Yes, yes, sir.
I am having some actually I am busy lot of, because that's why I have not conducted any session for last 3-4 days.
सर वो वाटर टैंक का भी चल रहा है ना, डिजाइन ऑफ वाटर टैंक का भी क्लास चल रहा था कल, वो भी हुआ है.
हाँ.
ये भी हो जाएगा, पहले का भी बच्चा है सर, तो सब वो सब रिवाइज करना पड़ा. फिर ना क्वेश्चन कुछ पूछूंगा सर आपसे, डाउट क्लियर जब तक नहीं हुआ फिर.
Okay.
यस सर, बराबर है सर उनका भी.
ठीक है, I don't have any issues, but only it will there will not be a continuity like आज सेशन होगा है तो परसों immediately होगा, because up till 19th I will be busy, because I am just switching my job, so I'm little busy with that. So after 20 we'll have the other sessions.
ओके सर, कोई इशू नहीं है. जब तक डिजाइन, जब वो चलेगा सर, डिजाइन ऑफ वाटर टैंक चलेगा.
हाँ,
वो चलेगा सर.
I don't have issue. You just communicate to the session organizer, so that they
Okay.
can organize it accordingly. I don't have any issues.
क्यों सर? सर आप पढ़ा दे रहे हो, मैं उसके बाद आप पढ़ा दोगे, फिर हम लोग को टाइम नहीं मिलेगा रिवाइज करने के लिए, फिर आप आगे बढ़ोगे तो उससे कोई फायदा. उससे सिर्फ कोर्स भागेगा. या हम कोर्स कॉलेज में कैसे कोर्स होता है कि एग्जाम आ गया जल्दी जल्दी पढ़ाओ, लोग बच्चे सब अपने पास होने के लिए पढ़ लेगा, वही था. यहाँ वो चीज नहीं सर, ये चीज प्रैक्टिकल अप्लाई करना है.
नहीं वो तो है. और आप ऐसा भी वो सोचिए कि अभी खत्म हो गए तो आगे कुछ नहीं रहेगा, because there are some students from I think first or second batch, I think for whom I have conducted session almost last year or 1.5 year back. Still they are sending some messages and asking queries. So I'm still replying to those queries. So it's not like that the session is over, it means that the guidance is finished. So if you have any query anytime, you can just send me a message. Only thing is that whenever I'll get the time, only during that time I'll respond to your queries.
ओके सर.
Yeah.
Yes sir.
Okay, so I don't have any issue in continuing after 20. So you just inform to the session people so that they can organize accordingly.
ओके सर.
So I think this Excel is shared in the group, right?
यस सर.
So you can go through it. If you have any doubts, then we can have a call or we can discuss it the next session as well.
यस सर. और एक पूछना था सर, जैसे एनालिसिस हो जाता है, फिर उसके बाद सेक्शन कंफर्मेशन हो जाता है डिजाइन द्वारा, वहां से आउटपुट पे शेयर फोर्स, बेंडिंग मोमेंट्स, ये वैल्यूज लेके फिर हम कनेक्शन डिजाइन करते हैं,
राइट?
तो इसके बाद फिर फैब्रिकेशन ड्राइंग के लिए फिर वो अलग सॉफ्टवेयर का इस्तेमाल करना पड़ता है, जैसे टेक्ला है, SDS2 है, फॉर द फैब्रिकेशन पर्पस, फॉर द शॉप ड्राइंग पर्पस. तो वो भी सीखना जरूरी है या ये ड्राइंग्स हम AutoCAD पे भी कर सकते हैं?
नहीं, see, the thing is that both the concepts are different, right? If you are engineer, then you have to design the connections only. So you don't need to draw the connection, or you don't need to model it in Tekla, right? So what knowledge you should have, that what is connection, for what load it is designed, how many number of bolts I have to provide, what type of configuration I have to provide. That is our responsibility. When it goes to the Tekla or SDF2, then designer, or we call it as a civil draftsman, those persons will model it in the Tekla, and if there are any clashes, or if there is any space adequacy, if there is not sufficient space to put that much connections there, then we have to think somewhat alternate connection type. But we don't need to learn Tekla or SDS2, because it's not a engineer's job, to be very honest. Because
Yes.
at the initial stage of my career, I did the detailing also for the concrete, but that is not our job. Our job is as an engineer, our job is to design the structure and
Yes, sir.
give the markup to some other, so that they can uh, prepare a drawing out of it.
यस, परफेक्ट सर, परफेक्ट। और जो भी ड्राइंग प्रिपरेशन जो होता है तो वो AutoCAD पे ही करते हैं फिर सर?
There are AutoCAD is now very rarely used, or you can say it will be used for only some specific drawings. Nowadays there is SDS2, Tekla, then SP3D, PDMS, E3D. So many softwares are there from which we can extract the drawings, or GA. For fabrication drawing, mostly Tekla and SDS2 is used, whereas for extracting the drawing or preparing the drawings from the 3D model, nowadays SP3D, E3D or PDMS, PDS, all those softwares are used.
ओके, तो ये एनालिसिस एंड डिजाइन होने के बाद वो सीखना जरूरी है सर फिर, या
not required? As an engineer, you don't need to learn SP3D or any other software. You have to only review what type of connection you have given and what is modeled by the designer. That you have to review. You have to perform the clash check, because there are when we go into the industrial structure like oil and gas or any other fertilizer and other industries, in that case there are some other disciplines as well. So they put their utility as well, like when electrical is there, they put their cable trays. When piping is there, they put all the piping. So we have to check the connection what we have provided, or configuration of connection what we have provided, whether that is is it sufficient, or is it have, or that connection has a sufficient space to, so that there should not be any clash with the other discipline. That only we have to review. If it is not possible to provide the connection in the available space, then we have to think of some other type of connection or some other alternative. But we don't need to learn these 3D modeling softwares. Just only for the interest you can learn, but that is not our job as an engineer.
yes, yes. Thank you, sir.
Any other queries? We should have knowledge of those softwares, so that at least basic knowledge. So we should understand what the other person is doing. So we can guide him, or we can check what he is doing. If he is doing something wrong, then we can.
Yes, sir. Yes, sir. Because in earlier, my first job after my engineering, I was in Nelsoft. There I was using that SDS2 and Tekla for the detailing purposes. So I had 1 year of that experience.
Yeah, I was a part of Nilsoft for 6 years, but initially I worked only 2 years on that detailing part. Then I moved into the design part.
Yes, yes.
So Nilsoft is only for the detailing part, not
Yes, purely Teleform. Yes.
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 it has a certain limitations, or the growth of the person is limited in that job. As an engineer, you cannot grow in that field, detailing field.
Yes, sir. There will be limitation for our growth. Yes, sir. Yes, sir.
Yes. Okay, so still we are left with 4 connection types and one gantry girder design session. So in next session we'll go through the 4 connection type and probably one more session for the gantry girder design that we'll have in next week. Maybe on 21 session and 22nd another session. Okay.
Okay, sir.
Yeah. So you go through these sessions and let me know your queries.
Yes, sir. Yes. Done, sir. Thank you, sir.
Yeah.
Thank you, sir.
Good night, sir.
Good night, sir.
Good night.